The first example is on page 386 of your textbook. It says a nail located on the circumference of a water wheel is moving as the current pushes on the wheel. The height of the nail in terms of time can be modeled by the graph shown. How can you determine the equation of a sinusoidal function from its graph? Well, we can get the equation if we know the values of a, k, d, and c. And all those values can be obtained from the graph. So let's get started here. A is actually going to be the amplitude that we're going to get from the graph. So amplitude is the difference between the maximum and minimum values divided by 2. And looking at the graph, the maximum is 3, the minimum is -1. So 3 minus -1 divided by 2 gives us an A value of 2. Next, we're going to determine K. K is the number of cycles in a span of 360. It can be found by taking 360 and dividing by the length of one cycle. So from our graph, if we go from the first maximum to the second maximum, we can determine the length of one cycle, and that cycle is going to be 10 seconds. So 360 divided by 10 is 36. Next thing we're going to determine is D. D is the phase shift. So D depends on whether we're going to use sine or cosine to model the graph with. So if we're going to use the cosine function, we just have to see how far the maximum is away from the vertical axis. So in this case, the maximum is on the vertical axis and it is 0 units away from it. So D is 0 if we're going to use cosine to model this graph with an equation. If we're going to use sine, we have to see where the function is increasing along the axis of the curve. So since we don't know where the axis of the curve is, we're going to leave that for now. Now to find the axis of the curve, we can use the formula, and it's going to represent the c value in the equation. The formula is just the average of the maximum and minimum values. So I'm going to take 3 as my maximum, and I'm going to add -1, my minimum, and divide that sum by 2 to give me 1. So the axis of the curve's right here. Now I look at points along the axis of the curve and see where my curve starts to increase. Well, here, as I go from left to right, the curve is decreasing, but at this point, the curve is increasing. How far is this point away from the vertical axis? Well, it's 7.5 seconds away, since every square is 2.5, because I have 4 squares and they add up to 10 seconds. 10 divided by 4 makes each square 2.5. Okay, so 2.55, 7.5. So in this case, we would have 7.5 as the phase shift if we're going to use the sine function. Okay. Now that we have all this information, we can write the equations, and you can model it using sine or cosine. If I'm modeling using cosine, I would have y is equal to a cos times x, x minus d plus c, and then subbing in the values. For a, I have 2, for k, 36, and for d is 0, so in brackets I just have 36x, and my c value of 1. The other option is to model it with sine. So subbing in the values, I have 2 sine times 36, or bracket 36, times x minus 7.5 plus 1. Okay, so the difference is in the phase shift, everything else is the same. Another option, of course, would be to model with negative cosine function. So when you're using the negative cosine function, you're seeing how far the minimum is away from the y-axis or the vertical axis. So in this case, it's going to be 5 units away. So alternatively, we could have written y is equal to -2 cos 36 x minus 5 plus 1. You could have also modeled it with the negative sine function, and this time you're looking for a point along the axis of the curve where the function is decreasing. So this is the point, and this point is 2.5 units away, or seconds away. So if you're using the negative sine function, it would be -2 sine 36 x minus 2.5 plus 1. So all these are alternatives, but these are the first two are the most common. Okay, let's look at another example here. Here we're not given a graph, but we're given information in words. It says a sinusoidal function has an amplitude of 2 units, a period of 180, and a maximum of 0.3. Represent the function with an equation in 2 different ways. Okay, so you can just draw a little picture of what we know. This is not necessary. This is just to help you visualize the problem. So we know the maximum is at 0.3. And if we're at the maximum here, and we go down the amount of the amplitude of 2 units, we end up at the axis of the curve. So the axis of the curve will be at 1. If we go down the amount of the amplitude again, another 2 units, we'll end up at the minimum value of -1. And then it'll start going back up. So it looks like this, and it says the period is 180 degrees. So from the first maximum to the next maximum, we're going to have 180 degrees. So this is what the graph looks like. Now we can find the equation. We know A is 2 units, that was given. K can be found using the period of 180 because it's 360 divided by the period. So 360 divided by 180 gives us a K value of 2. D is the phase shift. So if we're using the cosine function, it's going to be 0 because the maximum is 0 units away from the vertical axis. If we're going to use the sine function, okay, we're going to have to determine how far this point is from the vertical axis, okay? And this is a point on the axis of the curve where the function is increasing or it starts to go up, right? Now, how do we do that? Well, this is 3/4 of the way from 0 to 180. Halfway between 180 is 90, and halfway between 90 and 180 is 135 here. Okay? So if we're using the sine function, we're going to have to use 135 for the phase shift. Okay, you could have also used the negative cosine and used 90 for the phase shift if you wanted to, or you could have used 45 for negative sine. Now for the axis of the curve, it's 1. So modeling this with the sine function, I get y is equal to 2 sine bracket 2x minus 135 plus 1. And if I model this with the cosine function, I get y is equal to 2 cos bracket 2x plus 1.